Okay, as we start lab, just want to point out one more thing with the website. I changed the link here. I am putting things like the lectures after I put them up before the lecture so you can see it there, but it's not updating. You can see the lecture slides, the stuff like when students work problems, that's actually, you can watch it live if you want on your computer using OneNote. And I sent everybody links, but that was like the first day of school. But I've updated the link here so you can just click here. God only knows what's going to happen on my computer here when I click it. But okay, it's bringing it up in the web browser. And then you use your Union College Microsoft account. That is the one you set up for getting your free Microsoft Office stuff. And then you have access. So you can see, oh, that's the wrong class. I updated it. As God's my witness, I updated the link. But apparently I have to update it again because this is last year's class. So I'll do it again. Sorry about that. It's embarrassing because I was sure I had it right. It should have brought you to this class here, which, oh goodness. There we go. It has right now the lectures for the first 4 lectures and calculus, the first lecture. In homework, here's the calculus solutions we just did today, you guys. And the laboratory stuff. So I just want to make sure you know where to find that stuff. Hopefully that works out conveniently for you. On your lab reports, make sure that at the top of your report you have Introduction to Motion. That's the title for this lab. And then the purpose, there really is not much wiggle room. Remember, the purpose is my purpose for you doing this. So that's one that you want to reflect what I wrote here. So make sure your purpose, just write down these, 10 words or whatever it is for the purpose. And then make sure you have my name and your partner's name with something to designate that it's your partner. Put my college roommate. And then, of course, the date. And that's the first 5 points, and they should be the very easiest. Obviously, the title is there, so we can quickly identify, yep, this is the right one. The purpose, because we want to make sure everybody has realized what the purpose for that activity is. So as you can see, the purpose for today's activity is to discover the relationship between position time graphs and velocity time graphs. So we're going to be looking at these graphs. And of course, I have all of this background theory here. There's only one equation. So you need to have that in your equations, and you need to have v is speed or velocity. In this case, once again, it actually technically is a one-dimensional velocity. Plus means going away from the detector. Minus means going toward the detector. And then x is position, and t is time. So you need to have the equation and those definitions. We're not going to use the equation anywhere because the computer is going to be doing all the calculation for us in terms of that equation. The apparatus we're going to have is the Pasco 815 Universal Interface and the Pasco Motion Sensor Tube. And I'm going to actually grab some of these. I went through and carefully located everything last class period. One of these is missing. I think I brought it in there, but it might be sitting on my desk in my office, so I'll take this one just in case. So this is the universal interface here. This is the motion sensor. That's all of our equipment. Now, in connecting these up, so what's today going to take more time than it usually will? Just using the software and hardware for the first time. Always when you use a transformer, like to charge your phone or your computer or something, you really should plug it in before you connect it to your device. Because with transformers, you're going to have a power surge when you plug it in. and it's not so good for your device if you have it connected when you do that. So there, I've powered it up, and then we have this cable here for connecting to the software. And I'm going to live life on the edge. No, I'm not going to live life on the edge. I'm going to use the main computer rather than my tablet for showing you how the software works. If I can get this connected. The USB micro connection is one of the sillier connections, in my opinion. I feel like it should be. Okay, so there I have that connected. I'm going to log in this computer. Oh yeah, you see, I did bring the other one. I just brought one we had at home. I'm going to log in here so it can go through its startup stuff while I continue. The next thing you're going to be doing is connecting this. It actually doesn't matter which of the 4 different places you put it in. Notice this thing here can rotate. You're going to want to just set this so it's at 0. On the top, it has a picture of a stick figure person and a cart. Surprisingly enough, that stick figure represents you. So set this little slider so it's on the stick figure. Put this in, it will only go in one direction. It has a slot on the bottom, so it'll only go in one direction. And of course, you power this baby up. It should go through those lights blinking, and then it should just have this one. It should just have that light on because this is connected. I'm not sure why that light's not on. We'll hope that that's not a problem. Now, the next step is to start up your software. And for that, I change over the computer because I decided not to live life on the edge. And so up here in the Physics 151, I cut things down. You only have one well, there's sound demo, but Lab 2, Intro to Motion. Double click on it. It's kind of complicated at starting a program. I told Ashley I didn't need her. I should have had her set up computers. So we'll come up here in a moment. It will. Well, while that's coming up, what we're going to be doing is simply following instructions, walking toward or away from this detector, and looking at graphs that are created when we do that. See, it's coming up. Just not fast enough for my taste. So the software is called Capstone. By the way, you might notice this. The hardware is made by Pasco. That's Paul A. Stockstead Company. He's a Seventh-day Adventist person who has a huge business of making laboratory equipment for high schools and colleges. Because he's a Seventh-day Adventist, he gives us a nice deal. So I like to at least always mention that since he is supporting us. He's actually on the board of trustees at PUC, and we got like their demo equipment after they used it for a year. They give it to us, which was cool. Okay, so here I have a graph. Does this distance versus time? Down here at the bottom, see that record button? If that record button is red, you're good to go. If it's not red, that means you have a problem like your USB is disconnected. See how the color changed when I disconnected the USB? You also could hear the computer make some noise when I connected it up or disconnected it. So I connected, it's good. Also notice that there's 3 tabs up here. We're going to start with distance versus time graphs. And I'm only one person, so I'm going to ask for somebody to walk around for me. Who wants to walk around for me? All right, come on up, Ryan. He'll be like okay. We joke that Iowa stands for idiots out wandering around. Since I said I want somebody to wander around, anyway. So, yeah, well, first thing is you need to make sure that you're standing in front of this so it sees you. And then I'm just going to start by clicking on the record, and you hear it ticking, and then he's going to walk and then come back. It won't measure much farther than what you did. Okay, that's what I needed. Thank you, Isaiah. So it tracked his position as he walked around. And so you can see, the slope went one direction when he was walking away from it, another one when he was walking toward it. Here's when he was stationary. And you're going to be asked questions and answer questions about that. So obviously I'm not going to go through every step of the lab. One thing I do want to point out is, I think I said in here and I forgot to delete it, not to delete data until you're all done. Okay. Guess what? Your computers don't have that much RAM. And so after you complete each section, do delete all of the experiments. So how do you delete experiments? Well, let me take a second one here just so I have two. This one's going to be really boring because, of course, it's not seeing anything. Okay, so now I have two sets of data. It shows both of them on the graph. I'm going to show you many things here. First is, if I click on this triangle that kind of looks like the Google Drive symbol, it shows run 1, run 2, and run and prescribe. I can turn off run 1. Now it's only showing run 2. I can turn off run 2. Now it's showing blank. You're like, uh-oh. Turn on run 1. There it is. Prescribe, there's something that I put in that you're going to have to try to match. So you can turn on and off the display for different things. First thing to note. Second thing to note is the auto scale. This button right here is the auto scale button. Doesn't do much for that flat line. Oh, I might have. Now it says scale both axes, so it's not fixed. Let me go to run 1, auto scale. Oh, it's auto scaling including the prescribed. You don't see it, but it's auto scaling for that. I don't know. It should have adjusted the scale better. I am not going to fight it today. You can manually scale by clicking on the numbers. You get that up-down thing, and then you can adjust the scale. When you make your graphs, adjust the scale so your data fills the entire page. We don't want to just be small. So if you took this data and you have it like this, you can't really see anything going on. So we want to adjust the scale so we have the data fitting the screen. And there's nothing going on there, so I'm just adjusting the time. Once again, so my data fills the screen. So make sure you do that. Remember, you're turning in PDF lab reports, right? So here comes the next tricky thing. We need to turn in a bunch of pictures. I tried to use bold text in your lab guide anywhere you're supposed to print something. I also use bold print anytime you're supposed to sketch something. You're going to get to a point where you're going to sketch a prediction and then do the trial. Make sure you sketch the prediction before you do the trial. When it's time to take a picture, this little icon is supposed to be it's supposed to be a camera. And so that takes a picture. It'll have 3 different settings here. The entire workbook page will take a picture of everything. The page content will be everything that is inside. Well, let's just look at them. Here's the entire workbook page, the first picture. The second picture will be the workbook content. And the third picture will be the workbook display, which in this case will be exactly the same as the content. Now you're saying, okay, you took those pictures, little things flashed up, and I have no idea what you just did. How many people are with me on that statement? Well, not many. I expected more. Over here, so this little thing here that looks like a notebook, that opens up the journal that has all of your pictures. So here's the first one I took, and you see it has all the stuff that was on the screen. And sometimes closing on your laptops is a problem. Here's the second one. This one is just showing the display. It doesn't have the edges of the screen. It just has the graph. Oh, excuse me, that wasn't display. That was the page content. And then the last one is the display. That's, again, just the single graph. If I'd had multiple graphs and it was on display, it would only be a picture of the one that I had highlighted, not the other ones. So that's the difference. So for this lab, it wouldn't matter if you chose, okay, get back onto here. It wouldn't, notice I couldn't choose here. It wouldn't matter if you chose content or display. Either one would work the same for this. Here it's one graph. Here it's one graph. So all of them would be the same regardless of which one you selected. I'm going to go ahead and close the journal. Oh, yes. Remember the lab guide I told you, or if you read through my little personal lab report, I had the wrong picture. Here's what happened there. I'll show you exactly what went wrong. I had 4 pictures. Well, I had 5 pictures and I wanted to keep 4. I clicked on the wrong one and went to delete. And I deleted the wrong one. That is what happened. At that point, the picture was gone. The data was already gone. I was stuck. So be careful with those pictures that you don't delete one you need. When you're all done and you're ready to save them, go here to the print journal and make sure you save it as a PDF. So Microsoft Print to PDF, print, give it a name that's useful to you, and then it'll save a file on your computer and then email that file to yourself so you have it. I'm not going to worry about saving it.
Automatically email?
No, you have to open up Google Mail. All right. Yeah. I probably broke things because it says still printing journal because I hit cancel. God bless me. Apparently that's bad to cancel because it doesn't like me. Well, I'm going to shift back to the instructions now because that's enough on how that works for today. Your scientific method. First of all, your observation should be on something that changes speed. So something, like I drop a ball, it speeds up. Or my classic example, I see Ms. Leslie, walking to class. She looks at her watch and then she runs. That's my observation. And so my hypothesis, she must have looked at her watch and said, oh, I'm late to class. And so she ran, because when she runs, then it's going to take less time to get there because she's going at a faster speed. And then my prediction of the hypothesis is, well, the slope of a graph shows the speed, so when she runs, the slope should be steeper. And then, or when anyone runs. And so then your test is going to be what happens to the slope when you go faster or slower. Another option would be going toward it and going away from it. So that's what the kind of thing you should have for scientific method here. Right? We don't want any confusion about what's expected, especially as you're learning. The procedure, remember the procedure starts here where it says procedure, and it runs down here to the last question, question 18. A lot of questions today. So write this out. It should be complete enough that somebody who knows how the physics stuff works can do it. But succinct enough that it only takes at most half a page. Right? So you don't want to write all of this out. You want to summarize things. And obviously you don't need to say anything about how the software works or anything like that. You should, when you have the apparatus, and most people have this, have a picture that shows, here's my universal interface, here's my motion sensor, and here's me walking back and forth. Right? Something just shows how things are set up. Okay, so for the procedure, you're going to start. Yes, I totally screwed things up here. It's still at where it was before. I am going to kill it because that's one of my superpowers. So what you're doing here is in the first task, you explore how the slope varies with speed, and you have fast versus slow. I want to emphasize that fast is not running. We want to maintain a safe environment. We don't want people running and potentially slipping, falling, or hitting things. So fast just means walking like this, whereas slow is more sedate speed. So fast and slow is a comparative thing. It's not like I'm going to run fast. And toward and away. Now, you're working in groups of 2. We had 2 people drop the class. We still have an even number of students here, so groups of 2 works fine. And so I want one person to walk away quickly and toward it slowly. The other one to walk away slowly and toward it quickly. That way each person has one away and one toward, one quickly and one slowly. And so you're going to go ahead and you're going to take those 4 trials. And then notice it says sketch qualitative graphs. What does qualitative mean? It means you're just showing the shape. It's not an exact graph. So your qualitative graph will be that's backward, of course. And it's going to be something like, and I'm going to do something that none of your graphs will look like, but just showing the shape that you got. You don't need to have, I've had some people who spend a lot of time trying to make it go and look exactly right. Doesn't need to be exactly right, just needs to show the shape, okay? So those graphs should go quickly. You should draw your line and you're done. So you're drawing qualitative graphs of what they look like, and then you describe the differences in the graphs in the same direction but at different speeds. So that is, how does the graph of walking quickly compare to the graph of walking slowly in the same direction? And then for the next question, you're doing the ones that are the same speed but opposite directions. So how does quick compare to slow? One of those 2 is going to be the test of your hypothesis. So when you have the hypothesis test, you don't skip it. You say, I'm going to compare the graphs of walking quickly versus slowly, or compare the graph of walking away to the graph of walking toward, and what condition would be confirming your hypothesis, which one would be disproving it. When you go through the steps of the procedure, then you're going to have all of the procedure. You're not going to skip saying, oh, well, I mentioned that. You're going to have all the steps of the procedure. So you're going to have a little bit of overlap there because you're saying, I'm going to compare these graphs. And then down here, you're going to say, I'm going to walk away slowly, away quickly, toward slowly, toward quickly, and collect data to look at the graphs. That's the same thing that you were doing for the test. Then you're going to sketch a new graph of what you think will be produced when a person starts. So it gives you specific motion, and you're going to draw a graph of what you think that's going to look like. After you've drawn that prediction, then you're going to actually walk the walk and compare how the graph really looked to what you had predicted. And so on. It says now turn on the prescribed data. Well, I showed you how to turn on the prescribed data, but now I want to do it again because I have things running again. So which of the icons is the one that's going to allow me to turn on the prescribed data? One of the icons up here. The triangle, right. Click on that. Now see, I clicked on that, so now it's different, but I got to click on the arrow to see prescribed, turn on prescribed, and then you're going to try to match that. And each student, not one per group, but each student needs to do their best to match it and save their version of it. So in your graphs, you're going to have, let's say the partners are Leslie and Nathan. So there'll be Leslie's version, there'll be Nathan's version. Nathan will put his version in his write-up, Leslie will put her version in her write-up. So you're going to try to match that, which is not as easy as it seems. You'll find out. Okay, at that point, we're going to get to here, describe how you would move to make each of these graphs. And then I said, don't try this because you could hurt yourself trying to do some of these graphs I made. So you're just describing it. Then we're going to go to tab 2, velocity versus time graphs. Remember, the purpose was to understand position versus time and velocity versus time. So we're going to do essentially the same thing, but now we're going to look at velocity versus time instead of position versus time. So you have all of the same things you're doing there through question 14. And then finally, we have 2 graphs now for section 3 because we're going to compare the graphs of position versus time with speed versus time. So I think that you'll be able to go through all of this without too much difficulty. I should show one thing. We have here finding the slope and stuff. Leslie, you're close. You want to just stand up so I can get some data?
You just want me to stand?
Well, I'm going to have you move once I make it start ticking, yeah. Yeah. Okay, so go ahead and walk away. Okay, now what I'm going to do is I'm going to find the best fit for when Leslie was walking away. She was walking toward the detector here. I don't want that in my best fit. And so I'm also going to turn off the prescribe just so we don't have that in the way.
Can you switch?
Did I not? I thought I'd switch the screens. You know what I did? I went around in a complete circle, didn't I? Just like I just did there 2 times. I'm pretty good at this game. 3, not 4. Okay, so there we have Leslie's data, and I only want to fit this data here. So the first thing I have to do is I click new. Yes, click this one here that has the 3 dots over a pencil. And I'm on the wrong graph. Click on the right graph and do it. And it puts a box on that graph. Then I'm going to put that box so it highlights the data I'm interested in. I can do things like this sigma gives you statistics. So I can turn on all of these. And if I click on the sigma box, now that the arrow gave me the options, now if I click the sigma box, it shows me the maximum, minimum, standard deviation, and mean inside the box. If I hadn't put the box, it would have done the entire data set. Well, what I really want to do here is a fit. So I clicked on the arrow. I want to do a linear fit. And so mx plus b. And there I have a fit. And you can see the slope for that data for her walking was 0.435. What does that tell you if the slope of the position versus time graph was 0.435? So what?
Positive.
Okay, it's positive. But what physically does that mean? What does the slope mean? Okay, her speed is 0.435 meters per second. And then this y-intercept of minus 0.680, that's where her position would have been at time 0 if she had always been at that speed, which she wasn't. Now, if I look at the graph of position, screwed that up, of velocity versus time, I should be able to take my box and put the box over the same data points. So there I'm covering the same data points. And then the average of that should be her average speed as well. And you see it's not exactly the same number, 0.4148 versus 0.435, but they are similar. You can see here that it wasn't close to the same velocity throughout. She slowed down at the end because she was going back to her seat. And she was reasonably constant in that middle portion. Why are they different? Why is the average different from the slope? A fundamental math question rather than a physics question. Not sure? The average is taking each point and weighting them exactly the same. The slope is not. The slope is looking for a continuity in the fit, and so they're using different methods. So that's why they come up with a different value. If it was a perfectly straight line, they would be exactly the same. But it's not perfectly straight, so there are different methods, you get different result. And so that's what we're doing with the last part. So you need to be able to find the average of the speed and find the slope and compare the two like I just did. Any questions before we get started? DJ?
How many of those are there?
There are 10. And we have 9 groups, so we're in great shape. Other questions? All right. 2 people in a group. You can change your partners every single lab. I don't care. I assume that your partners won't care either.